Assalamualaikum to Dr. Firza. We are from Group 2. We'll present about our project, which is straw block greenhouse. First of all, I will introduce myself. I am Nur Shafika Ismail with metric number 201165. And these are my group mates. Nur Shafika binti Saji 201156. Wan Nur Izati Sahira binti Wan Ahmad Kamal 201329. Nur Shafika Sikang binti Muhammad Azroy 201253. And Siti Raudah binti Muhammad Rahim 201148. Straw block greenhouse. It is a structure with straw block that act as an effective renewable thermal insulator. Straw block is a combination of insulation and bark provides a great platform for effective greenhouse construction. Straw block construction is a sustainable building option in terms of both resources and energy required for heating and cooling. So it been used as one of the material in greenhouse construction. Straw block greenhouse has a straw block wall on each side for efficient plant growth and easy removal of the walls. The straw bricks are utilized to insulate the greenhouse and walls and not walls, while the frame serves as a glass pillar. The roof are primarily constructed of transparent material such as glass, where it allows plants to grow in controlled climatic conditions. Other than that, the foundation of the greenhouse is made from a rubber trench foundation with an earth cap. Therefore, it is the cost-saving greenhouse, but it is recommended to use polycarbonate greenhouse sheet for the ceiling because it is sturdy, double work, and lightweight material, which will allow a lot of sunlight and at the same time will filter the hazardous rays into the greenhouse. I will pass the presentation to Noshafika Saji. That's all from me. Thank you.
Thank you to Nur Shafika Ismail, and I'm Nur Shafika Mtisaji will present about the advantages of straw wall. First, the advantages of straw wall is to gain effective heat transfer in greenhouse, to prevent the spread of plant disease, environmentally friendly, and high thermal resistance value. Next is the objective of the straw wall in the greenhouse. First, to differentiate thermal storage coefficient of its storage layer, the total thermal inertia, to investigate the heat transfer characteristic, temperature, heat absorption, release and loss of straw block north wall. And the last one is to reduce air pollution by reuse straw as straw block. Now I will present about the result and discussions for the straw block in the greenhouse. First is the moisture absorption and desorption characteristic of material. Based on this diagram, we can see that straw block has the largest relative humidity absorption, so it was a good material for the greenhouse. This diagram show that the disease in the greenhouse crops are high if the relative humidity is high. So straw block has low relative humidity, so it will decrease the disease impact in the greenhouse. That's all from me. I will pass the presentation to Siti Rauda.
Okay, so for my part, I will present about thermal properties of material and nuts wall. So we can see in table 5, which is thermal conductivity and volumetric specific thermal capacity of different nuts wall material. So in this table, it's state about material which is type 1 straw block, type 2 straw block, and polystyrene board and porous clay block. So block can store more heat and maintain a consistent temperature, and the value of the heat reservation layer and thermal inertia index for the straw block nuts wall is higher than the porous clay block North Pole. So it's allowing the greenhouse to prevent heat loss and maintain temperature during the winter season. So for value equation for energy and moisture, so we can see in this picture, the greenhouse is separated into 5 sections, which is the plants, the soil on the ground, the north wall, inside air and covering film. So the movement of energy and moisture exchange represented by the red and blue. So we can see that the exchange of the moisture in this picture for during the day and during the night. So this is the equation of energy and moisture balance and equation of air humidity, which is in daytime and nighttime. So the plant, soil and not soil absorb heat in the greenhouse and cause the energy loss. Soil on the ground absorb irrigation water and not soil absorb the indoor air moisture in the night time. So the soil and nuts will contain high moisture level in the night time. So the ground and the nuts will evaporate when the temperature is increased. For the next slide, I will pass to the next presenter.
Okay, Assalamualaikum, Doctor. So I will continue our group presentation flow. So I would like to present about air temperature and solar radiations. The temperature of straw block greenhouse on sunny days is higher even in cloudy day rather than clay greenhouse. The solar radiation is lower for both type of greenhouses. Thus, straw block greenhouse increase the air temperature in the greenhouse at night for plant growth. This statement has been supported the graph above. From the graph, we can see that the temperature outside is much lower compared to both type of greenhouses. Even though the differences between these two type of greenhouse are very little, but we can still differentiate that the straw block type of greenhouse has higher temperature compared to the clay type. So for the temperature of north wall, temperature of straw block north wall are maintained in high temperature at any depth. It have better thermal stability in night time. The thermal properties of straw block wall are better than clay block because store more energy at deeper depth. So this statement also shows from the graph on the left side, and the black line are and the black line are presenting clay type, while the red line are presenting straw type. So for calculation of energy analysis of greenhouse, the equation are used to calculate Q for heat transfer per unit area, while capital Q, which means heat transfer of the entire area. So for the heat transfer per unit area, the formula is the sum of multiplication of heat flux by time, while to calculate the heat transfer of the entire area is equal to heat transfer per unit area times area per meter square. On our right side shows the table 7, which is heat absorption and heat release of surfaces during March 10 to 25th of 2016. So this table shows two types of greenhouse, which is clay and straw. So from this, we can see that The total heat absorption and heat release of clay greenhouse has lower than straw type of greenhouse. Okay, that is all from me. I will pass my presentation to my next group member. Thank you.
Thank you, Shafika. Me one note is that we explain about heat flux of knot wall and ground. As you can see here, on the left is the heat flux of knot wall, and on the right is the heat flux of ground. So the value of heat flux of knot wall in straw block greenhouse is higher than the clay greenhouse. Besides, this type of greenhouse wall can release more heat in the night time. The heat flux of the ground slightly higher than the heat flux of the knot wall. This occurs because of the amount of sunlight directed to the ground is high. So in conclusion, straw block greenhouse consists of various heat transfer characteristics that effective to greenhouse operation. Alternative straw block wall procedure are examined in terms of expected thermal performance and straw material use. And third, straw block greenhouse wall absorb heat during the day and release it back into the greenhouse at night. And lastly, straw block greenhouse construction will be determined by a variety of criteria including space, location, money, and materials available. That's all from us, group number 2. Thank you.